Exercise 5F, determining rules. Today we're learning about finding exponential and logarithmic rules. What you need to be able to do is find key points using the graph of a problem or problem, and then use these points to create simultaneous equations and solve these equations to determine the rule. So you've been finding rules for every type of equation for a very long time now. We're just applying it to exponentials and logs. So you just need to know the general rule for each of them. So for your exponential, you've got y is equal to, and then you've got the various transformations. So a and k are dilation factors, b and c are left and right transformations. Of course, you can have some negatives, and a is just a base, the little a. Then you've got your log graph, which again, you'll see the same kind of transformations appearing. So you've got A and K, which are dilation factors, B and C, left and right transformations. Little a is your base, and of course, you can have transformations. So if there are two unknowns, you need two pieces of information. So just in general, for every unknown, you need a point. When you then will substitute those points into equations, and you can solve it simultaneously, whether that be by hand or by CAD, depending on whatever the question is asking you. Now, a lot of the time, they might give you some specific information. For example, they might tell you that there's an asymptote. So if you know what the asymptote is, you can actually substitute that directly into your value, given that there's no dilation, of course. So for exponentials, your asymptote is at y equals c, and for logs, it's at x equals negative b on k. All right, so let's give this a crack. So it says the rule for the function shown is this: determine the values of the constants of m and n. So I can see that I've got two unknowns, and hence I need 2 points. Now, the first thing I will always look at is, are there any special points that are given? Which in this case there is. There's the asymptote. So because we know the asymptote is at 2, and for logs, the asymptote always happens at x equals h, or in this case, it would be m. So I can straight away see that because the asymptote is at x is equal to 2, therefore m must be equal to 2. We've moved to the right by 2. Now to find n, it's just going to be a matter of substitution. So we do have another point. We're going to substitute that point into the equation, and then we will solve for m. So when y is equal to 3, x is equal to e plus 2, and then m we already found was 2, so I'll sub that right back in, and now we just need to solve for n. So 3 is equal to log e, then 2 minus 2 is just 0, so we've got an e here, plus 1. Now we know from our log laws that if the base and the insides match, then that's just equal to 1. So n will be equal to 3. So I'll just write that that's equal to 1. Okay, that's very nice and easy. So we end up with m equals 2 and n equals 3. Let's try it again with this graph. So we've got a graph of a log function. This time, this is the equation here. Determine the values of a, h, and k. There are 3 unknowns, therefore I need 3 points, and I can see that I have been given those 3. So the first thing again that we look at is special points. So the special point in this case is our asymptote, which is at x equals negative 1. We can tell straight away, given that there's no dilation, therefore that h will have to be equal to negative 1. The idea is that when I sub in the negative, it becomes x plus 1, and we know that means it's shifted to the left by 1, which is what we've done. So just be careful with the negatives there. Okay, now for our other two, we're going to have to solve this simultaneously. So I'm going to go ahead and just substitute both in. So 0 is equal to a log e, x is 1. And then we have minus minus 1, so that'll be plus 1 plus k. We'll see if we can simplify that any further. There's not much we can do, just becomes log e2 plus k. And then we'll have our second point, which is 0 and negative 2. 0, and again, because h is negative 1 plus k. Okay, so this can help us because, oops, I dropped the a off. We know that log e1, based on our log laws, is actually 0. So because we know that, we can tell straight away, like, well, 0 times a is just 0. So k will have to equal to negative 2. So because a has to equal negative 2, we can sub that straight back into equation 1. So we have equation 1, 2. I'll just keep working here. So we'll go sub k into equation 2. So that'll be 0 equals to a log e2 minus 2. I'll take the 2 over, and then I'll just divide by log e2. Okay, so those are our 3 values. H will be equal to negative 1, k will be equal to negative 2, and a will be equal to 2 log e2.